The graphs show the position of two identical waves at a time t. Find the phase difference between these two waves. First of all, a definition. The phase difference is a difference in angle, radians or degrees, just choose one option, between points on the same wave or similar points on two waves. And the idea is the next. There are two identical waves, it means they have the same time period, the same wavelength, and there is some shift. We can see that it's here. And one complete oscillation corresponds to 2 pi in radians or 360 degrees. And we need to find what fraction this shift is of one complete oscillation, and hence we find what fraction this shift is of 2 pi or 360, and answer is some number which is fraction of one oscillation multiplied by 2 pi or fraction multiplied by 360. So how to find it? We consider any wave, it doesn't matter what wave to consider because they are equal, and consider one complete oscillation. For example, let's consider this wave from maximum to the next maximum, so from A to B. We can see that there are no specific values on x-axis, so we can just count squares. So we can see the distance from A to B is 10 units. Hence, we can make proportion that 10 units corresponds to 2 pi or 360 in degrees. And our shift, we can see that it's just 1 unit, hence 1 unit corresponds to unknown value. Hence, x is 2 pi divided by 10, it's pi over 5, or if it's in degrees, it looks like 10 corresponds to 360 and 1 corresponds to x in degrees, hence x is 360 over 10 is 36 degrees, and it's required the phase difference. So it's pi over 5 in radians or 36 in degrees. So you can see that it looks like fraction, which is our shift of one oscillation, so it's 1 out of 10 multiplied by 2 pi if it's in radians, or 1 of 10 multiplied by 360 if it's in degrees, so it's pi over 5 or 36 degrees. And notice that if there is distance on x-axis, hence one complete oscillation, it's actually wavelength, because it may be given separately that wavelength is something, so you should write wavelength here. So wavelength corresponds to 2 pi or 360, and hence shift in meters or centimeters in the same units of length corresponds to x. Or if there is time on x-axis, hence one complete oscillation corresponds to time period, and here is time period, and hence shift must be in seconds or other units of time, and here maybe any unit of time, but it must be same units of time. It's not necessary to convert in seconds, it may be in time period in milliseconds, and hence shift can also be in milliseconds. And it's when we have two waves, but also the phase difference may be for the same wave, but phase difference between 2 points. For example, point A and point B, and we can see that A and B are shifted by a quarter of a wave length or time period, or by a quarter of one complete oscillation. Hence phase difference is 2 pi divided by 4, or pi over 2. For example, point A and point C, we can see that they are separated by half a wavelength, so phase difference is 2 pi over 2, it's pi, and it's called that they are in antiphase. And for example, point A and D, we can see that they are separated by a lambda or time period by a whole number of wavelengths, so such points are called to be in phase. So we can see that they are separated by one complete oscillation, so phase difference is 0 or 2 pi, and they are in phase. Or if there are two waves and they look like this, and you can see that they are shifted by half a wavelength, and hence phase difference is pi or 180, and we say that these two waves are in antiphase. If two waves looks like this, we can see that two waves are in phase, or phase difference is 0. And the next example, displacement time graphs are shown for two waves, each of frequency f and period t. The phase difference in radians between the two waves is given by. First of all, notice that the phase difference is measured in radians or degrees, and you can see that time divided by frequency is 1 over second, so option C is measured in radians multiplied by second squared, which is not true. It's not a unit for the phase difference. And also for D, we can see that also second divided by 1 over second, so it's also radians multiplied by seconds squared, so C and D are not true at all. And again, we need what fraction this shift, which is t, and notice that there is time on x-axis, so one complete oscillation is time period, and one complete oscillation, which is time period, there are no values, but time period is given directly, so we can write that time period corresponds to 2 pi or 360 if it's in degrees, and the required shift, which is just t, corresponds to x. Hence x is 2 pi, just apply cross multiplication, 2 pi t over time period, and actually it's the required phase difference. Or it just what fraction our shift, which is t, is out of one complete oscillation, and since it's time, so one complete oscillation, it's just time period, and hence the same fraction of 2 pi or 360. So the correct answer is A. And that's all for this question.